Hi everyone, my name is Alex Salgado and I'll talk about visualsimboat, a high-fidelity visual simulator for autonomous surface vehicles. So, I would like to start with the motivation and the need for this USV simulator. We have a lot of challenges in maritime autonomy because you have dynamic environments about waves and currents, a lack of synthetic data sets for AI training, and we also have a real world instance that could be avoided if you we use this kind of AI autonomous boats. And one of the main reasons is although we have built our USV, the cost to real test is so expensive. You have a lot of logistic issues. So is one of the reason that when you need to collect data every day, we need a kind of simulator. In my case, in our case, for visual tasks, to using computer vision and AI for autonomous situation. So have some simulators that have a lot of use in research, like Carla, Gazebo, but we have a lot of lacks in this kind of situation for maritime environment. So our purpose is create our all simulator visual symbol with a high fidelity visual for using AI tasks like training, like uh, generate images and videos about real world scenarios and merge with some kinds of sensors like GPS and LiDAR. The architecture here is a little bit simplified, but you have a simulator physical layer that simulates the movements of the boat in the ocean. We have another layer of simulated GPS and different kinds of camera outputs. And all data are collected and synchronized in real time in a JSON log system. So we can use this data to analyze in a different time and use and have a connection with Python API to create some remote control and controlled environment for example, imitation learning tasks. So the core features is using USV model, maritime dynamic, the buoyancy, wave interaction, vessel motion, navigation system. We can simulate waypoint based navigation and record all the trajectory. We have some sensors like cameras and GPS. We can control it programming by Python API, and all data are synchronized and we generate a JSON log capturing this data. The simulator is integrated with Cesium. That's a framework for real scenarios based in Google Earth, so I can point my both and simulate different scenarios in the world and collect this data. We put different cameras. Our objective here, our main goal here is to collect the data of cameras and to for a post situation to replicate in a kind of imitation learning. So we also have this camera in we configure in these hexagonal positions to have 3/6 visualization of the environment. And during the navigation, we collect all the camera and waypoints and GPS data for this project to use in a training for AI tasks. So yeah, was our experiment to test this. We used Unreal Engine and Cesium, and the code was running in a MacBook Pro in real time. We've simulated a lot of scenarios, different scenarios, for example, San Francisco, Amsterdam, Niterói, and Natal. So we can reproduce these scenarios in a short little time. After after run our experiment, we can create some kind of analysis like that and realize what kind of navigation waypoint the boat was executed, and all the cameras captured during this navigation. The camera was positioned in that way that I said before, and this is the workflow. For example, for a vision task, when I needed this data set for AI training. So first I need to prepare the scenario, configure the sensors, automate the navigation and that data capture. All this data could be annotated for ground through, and I can structure it in a JSON format to use in a training in different formats. So here is a sample of the output of the after running a navigation. So for example, here we navigate around Niterói, and I capture these images in different filters and generate this log with the main movement that was made to navigate, the GPS coordinate, latitude and longitude, the camera that was captured, the image camera that was captured in that timestamp, and I can collect all this data and put to run for 4 hours in different scenarios. So one of the strengths and limitations, we have a diverse synchronized data set with realistic geographic representation, so I can use it for every place in the world that was mapped for Google Earth. Also, so I can have a global scenarios, and all the code will be open source. Is open source. Limitation: we need a good computer with a good GPU or some card like that. We are using moderate wave dynamics to can improve it to be more realistic in terms of physics, and we can also reproduce more weather simulation, different weather situation. So in this way, we are focused on feature work for example, multi-vessel interaction, advanced fluid dynamic, extreme weather condition, additional sensors, specialized environments, and land-based hydrodynamic models. So for conclusion, the key contributions are comprehensive platform for autonomous vessel navigation research, so we can use it for different research areas in maritime environments, a high fidelity simulator for validated performance metrics, global geospatial integration for diverse test environments, so you can replicate different places in a 3D format in the world, open and extensible architecture for research advancement. All the code will be open source for community. The impact, one of the big impact is reduce the cost and the complexity of real world data collection. It's a big issue for us. in our research, enable safer experimentation and validation, accelerate the development of autonomous maritime technologies, application in security, logistics, and environment monitor. So thank you very much for your time. All the code will be posted here, and feel free to contact me and our team for any future questions. Thank you.